I want to go over specific questions. Shh. I want to go over a specific question. A lot of you guys did good. So 19, that's Ian's question. So we're gonna talk about 19, and the Will also kind of did that one kind of weird. So
Did it the right way 3 times and plugged it in wrong 3 times. But they
square root of 1 minus x. Okay, so immediately this looks like um maybe it looks like an arcsecant in some way, but it's not because of the number in front. The arcsecant is the axis in the front of the square root. So then I kind of says, well, if assume that this arcsine, then a squared must be 1. A must be 1. And u squared is equal to x. So u must be square root x. Well, the problem of here is you should set up this way. And then du should be 1/2 x to the negative 1/2 dx. Did you do that part? Okay, so that's going to be 1 over square root x. Now this dx. So dx is going to be 2 square root x du and square root 1 minus x. So this will cancel out nicely. So that's how you get 2 du of square root 1 minus x. So in this case, will be 2 arc sine of square root x over 1 plus c. And that's how you get this one. This one's really cool. This one's really cool. I think it's one of the things that you have to use a little bit of creative thinking to think about what this is. And also knowing the du. The problem is most of you guys don't do du. Like Will did not do du, and he's a good student. So that means some of you guys probably forgot to do du as well. All right, good, Ian. Okay, well that's good. Now, I won't spend too much time on 23, but 23, if you're interested, it's on the board. Alejandro did that one. He did a W substitution and even do a back stuff, and so it's a little bit more extensive. And I'm not gonna be worried about if you can do that because I won't never put that on the test. Actually, I probably not gonna put those questions on even the inverse trick. I probably not really emphasize. The only thing that I'm emphasized on two things. It's arcsine and arcsecant, arcsine and arctan, and a little bit of what we talk about today. But 37, that's another one. That's another, I think, is a very, very cool one. So 1 over root 2, 0 arcsine of x over square root 1 minus x squared dx. This one is actually talk about inverse trig derivative and inverse trig integration at the same time. Well, yeah, sort of. So u equal to arc sine of x. This is the first thing you have to recognize. And du is equal to 1 over 1 minus x squared dx. If you solve that, you should see that that's going to cancel. Square root 1 minus x squared du equal to dx. Then that's going to be arc sine, so it's u and square root 1 minus x squared. And this is a 1 minus x squared du. Now, at this point, I won't even plug in a boundary because there's an x and u. If you plug in boundary right now, how do we know they are x or u? So I will make sure everything's uniform to du.
Don't you change boundaries first?
Yeah, but I change it after, like this moment, because now I have everything in u. The boundary now can switch, so that's going to be arc sine of 1 over square root 2, which is square root 2 over 2, which is the only time it can happen is pi over 4. And arc sine of 0 is equal to 0, so it's pi over 4 to 0. End up to be a very, very easy question. So you use square over 2 between pi over 4 to 0. And now put it in a 1/2 in the front and just focus on square. And that's going to be 1/2 of pi over 16. square over 16. So it'll be pi squared over 32. Now, once you did it, you should check your answer. Once you did it, you should check your answer. See, hey, is my answer correct or wrong? Now, this question is a little bit more unique compared to any other questions that we did. Another one, 17. Did you guys do long division? Do you recognize Lena did not do long division? How'd you do U substitution? You can't do U substitution without long division. 17, I'll tell you the answer. I'll send you the answer. Hold on a second. 5.8. It's 5.7. 17 should be 1/2 x squared minus 1/2 natural log of x squared plus 1 plus c. You had to do long division, right? What did you?
You don't have to do the long division. And then I split it up. Yeah, and I split it up, and then you can just use like.
Oh, okay. Okay, any other question you're not sure about? Okay, I would like to talk about 29. Here 29 is just a very simple so this one's not arcsine. It looks like it's arcsine, but it's not. But if you see that there's a 1 degree difference, then you say, oh, I'll just do U sub. Why do I need to bother with arcsine? Arcsine is more advanced technique. So then you say U equal to 1 minus x squared. Du is equal to negative 2x dx. And then perfect, because du over negative 2x equal to dx. And that's equal to integration of x square root of u, and the dx is equal to du over negative 2x. X cancel out. And then now I can do u to the 1/2, negative 1/2 du. Now I can sub in after that. So b 0 is 1 is 1. This is 3/4, I think. 1 and 3/4. Is that right? Sorry, 3/4. And then it's going to be negative 1/2 u to the 1/2 times 2 between 1 and 3/4. And then this 2 cancel out. That's going to be negative u to the 1/2 compared from 1 to 3/4. So that means minus 1 minus square root of 3 over square root of 4. So it's going to be square root of 3 over 2. Or I can change the square root of 3 over 2 minus 1. So this is the final answer I got. For me, I like this question because that's more realistic on AP exam, because advanced integration technique like inverse trig very rarely show up. So if anything, I'd rather you able to do something that's basic. Okay, next question. So let's talk about today's problem. This happened in the AB test in the past, but very rarely that student knew what to do. But it show up on BC test a lot more. So right now you learn something like kind of like on BC, but it's not. It's still inverse trig integration, but it's just a different technique. So how would I integrate dx over x squared minus 4x plus 7? Any cool idea what we can use? So like the problem is like you guys kind of spill out stuff. You're not thinking. So think a little bit. Pause like 30 seconds. Think about what other things I can do in order to take integration of this. Now, think about also is more likely to deal with the inverse trig because we are in the inverse trig integrations. So is it any possible I can make that become inverse trig?
That plus 7,
Yeah. All right. Any ideas? So like Lena, you can just spill out stuff. Don't spill out process. Like a student that usually you want to process through before you answer questions, because obviously if I ask a question like this, it's probably not like a simple. So one day I was like asking like for example, I compare a couple of students. Like say, those of you guys know Omar. I love Omar. Um, he's very funny guy, and I asked him. I says, I went to Cooper's room. We said, hey, we wanted some good statistic kid, and I asked him, what do you think about Omar? And the Cooper has a very good analyzation about Omar because he had the same analyzation as Omar. Cooper says, well, if he just slowed down and think a little bit more, he's actually pretty good. He has a lot of logic. The problem when you ask Omar a question, he just respond right away without thinking. And that first intuition, that first reflection through your brain is not usually not tended to be correct in Omar's case. Actually, it matters in many people's case. Usually that first instinct is not necessarily correct. So learn to how to slow down and think, process a little bit more, like process like 15 to 30 seconds before you spill out answers, like without thinking, without processing through. So you will discover a lot of good students that they actually don't answer the question right away. And they think about it a little bit more. They think about probably 20 to 30 seconds and before they raise your hand, before they say stuff. So that first reflection through your brain, not likely to be correct. And even it's correct, that's only what 5% chance. So there's not worth to take that chance. Think about a little bit more. So any idea how to take integration of dx over x squared minus 4x plus 7? Yes.
What if you bring it all up and then split it up? Could you
Elaborate on that? That's a very, very scary thing, like what you just said.
like,
But elaborate, how would you do that?
okay, what if you did like you move up x squared, so like x to the minus 2 minus 4 x to the minus 1 plus 7 to the minus 1, and then I split it up.
So if you're thinking about like integral 1 over.
Bet, what do you think about that one?
That would
You,
You cannot bring up individually. So they are not multiplying. First of all, they're not multiplying. If they multiply, yes, you can move them all up, but you can also simplify also. But they are adding and subtracting, so you cannot move them individual pieces up. No, that's not. That's like saying this, right? That's like saying like 1 over 2 plus 1. Or I should put plus 3. And then we say, oh yeah, that's equal to 2 to the negative 1 plus 3 to the negative 1. That's not true because 1/2 plus 1/3 is 5/6, but this one is 1 over 5. So by think about actual realistic number, that is not correct, but that's okay. That's a good try. It's fine. Any other methods?
No, something fine.
Uh,
Get 6 or 1.
Let me ask specific student then. Ashton, let me ask you a question. Remember a long time ago when we did an algebra 2? Not algebra 2, in pre-calculus. Is there any way I can change it from standard form to vertex form? What are the two ways that you can change it from a standard form to vertex form?
I don't remember that.
How do you change a quadratic, a standard form, to a vertex form? Great question. Let's start with what is the vertex form? This is standard form. This is a vertex form. He's like, looks familiar. I don't blame you. You have Mr. Robinson. That's a good question from Mr. Robinson. Let me remind you what you can do in SAT. When you deal with circles, you have to do certain things. Come on, even my pre-cal student know how to do this.
Wait, what?
All this SAT whiz here. I got 700. A bit. Do you know?
No.
Oh, wait.
I know it's
Who says what? Somebody say something here?
Where?
Fabian, you say something? No? Lucas said complete square? Okay, good job, Lucas.
I don't know how to do it though.
I'll show you.
I tried to do that.
You take the middle term, divided by 2. No. N square. And that's equal to -2 square. That's equal to 4. So what you can do is you rewrite this equation on the bottom. I don't know how you guys did well on SAT. It is usually on SAT.
When we each got that one wrong.
Possible too.
That's the bomb had to let door.
Okay, so I add 4 here. In order to keep it balanced, like a balanced electron, you have +2 cation, you have -2 anion. So the same thing to keep it balanced, to keep it neutral, right? So it's going to be +4 and -4. Why? If you simplify everything, the +4 and -4 cancel out. I go back to before. Understood? And then I'll parentheses those 2 terms.
Oh, you.
And then that becomes x minus 2 squared plus 3. And that's dx. So essentially, if I expand the bottom here, I'm going to get the one on the top. But I write in a form that is arctan because integration of du over a squared plus u squared du is equal to arctan of u over a 1 over a plus c. So this is going to be arctan of x minus 2 over square root 3, 1 over square root 3 plus c. And that's my final answer.
No, it's not that.
Huh?
It's arctan and say big on plus. And what does that be? 1 over.
Yeah. Why not?
Yes, the 3 is a squared.
Yeah.
So
x minus 2 is
u squared equal to x minus 2 squared. And the u is equal to x minus 3. Remember, I always take du, but du is dx here.
X minus 2, not X minus 4. I think you might have missed up that word. U equals X minus 2 squared, U equals X minus 3. Thank you. So got it. So that, yes, that's out of there. 10% is
Yeah.
oh god, that's crazy.
All right, so this is called completed square. By the way, if it's on SAT, it will look like this. X squared plus 4x plus y squared minus 10y is equal to, let me see, 7. You have to complete a square here. Depend how the question's worded. Depend on how the question's worded. So depend on the question to word it. So what I will do is to avoid people using decimals, I can create a question. So instead of write down 7, I'll write down 10 like this. And I will ask you what's radius. And here's what I will do, because the 7 is going to come out a very nice radius as integers. But I hear you have to know your math, because if it's 10, then it's different, right? If it's 10, it's different. So then you have to take the middle term, you divide it by 2, you square, that's equal to 4. So you can have the plus 4 here. And negative 10 divided by 2 square, that's equal to negative 5 square. That's equal to 25. So it's plus 25. So this is a plus 4 and plus 25. This is equal to square root what? That's equal to 39, right? So it'll be x plus 2 squared plus y minus 5 squared. Now the radius is going to be square root 39, which is not going to be exactly nice number in terms of SAT, because you look on a decimal, you cannot tell how far the radius is. So look, I can write better question than SAT can write. If I were writing it, I will not write that you can look at the center and count how many square is there.
Never go to college.
Huh?
I got
For everyone.
Yeah, you got it, but can you find out the radius
Yeah.
in terms of square root?
Not in terms of square root.
In terms of square root.
It's around the decimal.
In terms of square root. What if I says, I say radius is in terms of square root of a, and what is a? So SAT is really stupid for us right now. It's very stupid because the people who write the question are stupid. Either they write questions too hard, or the question just came straight out, just plug in the calculator, and you plug in decimal, you're gonna get a straight answer. That's very, very stupid. If I were the SAT writer, I would never write question like that where you can plug in the SAT. I can plug in decimals, and literally the kid don't have to know anything. Yeah, just put in decimal. You can even find a mean on decimals. Do you know that?
Median.
Yeah, and standard deviation as well. So I'm trying to say is, the people who write the SAT test are I say that you, but it's stupid. Anyway, so I want to talk about another harder question. How much time I have? Good.
Wait, no, all the tiny boxes we have work period. Yeah.
Okay, so what if I have this questions? Yes. Okay, what if I have this question? What kind of trig function I'm doing here? What kind of inverse trig?
Wait, if x times 3 minus x. Wait. It's not it's x times 3 minus x.
No, it's
Yes, that's correct.
it's not arcsecant, and it's not arctangent. It's arcsine. Okay, so this one is actually very difficult. Like, When I was a student, I struggled with this one, but I just want to show you what happened. So 1 over, so instead of writing like that, you know how integration of arcsine is du over square root a squared minus u squared, right? And this is equal to arcsine of u over a plus c. Now, the problem is this one here is not good. So what I'm going to do is I'm going to write down in a certain way that to help you. So I'm going to write it in this way. So I want a minus u squared. So that means this whole thing is minus. So that means I have to have minus of x squared minus 3x. Think about why that is. If I distribute a negative sign, am I going to get negative x squared? If I distribute a negative sign, would I get negative 3x? Or positive 3x. Is that okay? So would you say this is the same as before? Would you say this is the same as before?
No, you need to do the stuff. Yes, it is.
Okay, so now we're going to complete a square. We're going to take this, negative 3 here. And what we're going to do is negative 3 divided by 2 squared. So that's 9 over 4. So what I'm going to do is I'm going to add 9 over 4 here. I'm going to add 9 over 4 there. If I'm adding 9 over 4, what do I need to put in the front here? Be careful what I say. Be careful what you say. Oh, Amy is right. Amy is thinking. Good job, Amy. I hear you. This one's distribute, so this, you actually didn't add 9 over 4. You actually subtract 9 over 4. So what you can do is you're going to add 9 over 4 in the front. So think about it. If I distribute everything, right? The 9 over 4 would cancel the 9 over 4 in the back. If I distribute a negative sign, would I get negative x squared plus 3x, which is the same as before. And you're like, oh, okay, well, that's not too bad. 9 over 4, 3 over 2. This is 1 over square root of, well, this is obviously 3 over 2 squared. And this is obviously x minus 3 over 2 squared. I factor it. And this is, the factor is really easy. Just put it right here. You can use the box method. You're going to get the same thing. Now, a squared is equal to 3 over 2. No, a squared over 3 over 2 squared. A is equal to 3 over 2, right? B squared is equal to x minus 3 over 2 squared. So B must equal to what?
X minus 3 over 2.
Good. So, no, so not B. This is U. This is U. This is U. Is that okay? So that is going to be integration of 3 over 2, 9 over 4, du over square root of a squared minus u squared. We have, now it's not 9 over 4, sorry, I'm going to change the boundary. What is the boundary here?
Well, you plug a 9 over 4 into the u.
What is 9 over 4?
9 over 4 minus 6 over 4, which would be 3 over 4.
3 over 4?
Yeah, it could be. 9 over 4 minus 6 over 4.
So 3 over 4.
And for the bottom one, which was 3 over 2. That's
So that'll be 0, right? Is that okay?
yeah.
So this will be arc sine of what? U over A. So what is U? U is here. But I'm going to do it U over A. What is A in here? 3 over 2, right? Between 3 over 4 to 0. So what's arcsine of 3 over 4 minus 3 over 2? What is that? 3 over 4 times 2 over 3. So 3 cancel out. That's equal to 1/2. So that means arc sine of 1/2 minus arc sine of 0. pi over 6.
Ow.
It hurts so much.
A very cool question. I like it, but I won't. Would I put this on the test? Probably kind of extreme, because the completed square is too many fractions to deal with. But if you will go to BC, should be a simple. It should be a simple questions. If you will go into BC. No ring. Are you going to BC? No. Okay. What?
Fabian looked at me sad, but he's really leaving the school.
Fabian. Fabian, maybe it's just disappointing.
I bet you said you can leave it. Yeah, but it's good enough to hope.
I bet it's coming back to take up BC.
You think it's self-study BC.